All right, welcome to Module 10, Part 2. And we're just going to quickly review. Horizontal access wind turbines are ones where the low-speed shaft is positioned horizontally in the nacelle system of my wind turbine. And they come in two types, upwind facing and downwind facing. These are typically three-blade point systems, and they're going to have rotation systems based on what components they need based on the amount of wattage I want to produce. There are both pros and cons to horizontal wind turbine access systems. One of the cons that exists is the weight at the top. And so if I'm concerned about needing to have a nacelle or a housing body that's going to hold things like my generator system, I am going to be concerned about balance and weight and counterbalance. And therefore, if that is something that I have to look at heavily, I might opt to build in a vertical wind turbine system. And one of the benefits of that vertical system will be that all the weighted things will be at the base of my module. Here's some pictures of horizontal wind turbine access systems, quickly talking about advantages, disadvantages, bringing into vertical access. So vertical access wind turbine systems have what would be in the nacelle. So the low speed shaft will connect to maybe a gearbox if I'm trying to produce a lot more power, which will then turn to a high speed shaft, which will then connect to a generator to produce. And all of that is actually on the ground. So that is something that I can put all my weight at the base of my system. And I'm going to actually show you the three original designs of vertical access wind turbine systems. And these three are they're substantially different from one another. So I'm introducing you to these three, and they're kind of like the flagship models. They're the first like them, and they're so different that it's important to know these three and then understand that out of these three designs, there have been so many plays on these designs. So if you begin to look up things like vertical access designs, you will see all different forms and shapes and things. But the three systems I'm introducing you to are like the three inspirational originals that everybody's basing all these new designs off of. And so without further ado, let's talk about the vertical access wind turbine design that is the Darius. So the Darius system is one where I have two wind foils, sometimes three wind foils, and they are bent into this egg beater shape, and they will rotate based on the wind smacking them and turning the low speed shaft inside the double blades. Another example looking down from the top on a Darius system. This is a three-bladed version of a Darius system, and this is a concept design of the Darius system that's been updated. Like I said, we've taken a model, so this is an original Darius, and then this, we have a concept that somebody built based off of that design, that original concept idea from the 1930s. Once again, down here, gearbox I have that goes into my generator system. So low speed shaft, gearbox, high speed shaft, generator to make electricity. Gyra-mills. Gyra-mills I like to think of as the double-bladed airfoil systems. They have kind of like two sides or three sides that stick out, and they'll be like little cups out on the side or little blade foils out on the sides. I've even seen ones that kind of look like they're Mickey Mouse ears, like these weird like tambian drum things out on the sides. And so these kind of look like this. They're these T-bar H-shaped structures, which can once again come in two blades or three blades, depending on who's designing it and how they're making it work. And the way they've set up these systems is that the highest weight is out on the wingtips. They're out here so that they can really catch the air out on the edges. And so they're held aloft out along bar structures. Now, Gyra-mills can be very fragile. In high wind speeds, they can take those blade tips right off. And so they're kind of a system that you wouldn't want to put too high aloft. They're a system that you're going to want to keep closer to the ground. On the other hand, if you're trying to produce power closer to the ground, something that's more around the height of a standard three-story home, then you might want to think of a Gyra-mill system. Because it is so weighty, it really needs to be close to the ground. You're not trying to play with something that would catch high wind speed. final system is the Savanis system. And the Savanis system is kind of easy to remember because they look like an S if you look at them from above. So if you look down at a Savanis system, it has sort of an S or a double scoop shape. Makes it kind of easy to remember. But these are the ones that kind of look like scoops or twirls. So you can actually see a little Savanis that has a little spin twirl to it. Here's one that is offset buckets. This is a home built. Savanises are something that you can go out and buy yourself a bunch of buckets today, cut them in half, offset them so that if you look down at the bucket from above, it has that S curve, and it can work as a double scoop. And it would just turn your shaft in the center. So that's a Savanis system for you to work with. And you'll see things that combine it. Even in that first slide when I was introducing vertical axis wind turbines, I had something that was a combination Darius system with a Savanis system in the center. So it was trying to catch both. You could see where that would create a lot of torque on the system, where you'd have a lot of kickback and a lot of fluctuation in frequency moving through your shaft. And so it would shake a lot. It'd have a lot of vibration on that system, making it fatigue easily. So there's a lot of mistakes that can be made with these systems. They're great for small scale. These are not something that you're going to produce over 100 kilowatts. These are small scale models. These can even be things that you would be comfortable building yourself. So that brings me to building a wind turbine yourself. Now, this is something that I'm a hobbyist, and I like this sort of thing. It is something that I've done back in grad school. I used to run a workshop where people would come and stay for the weekend, and we teach them how to build a small-scale wind turbines for themselves and then actually put one up on site. And it was a completely hands-on workshop that we would do. It's something that I've played around with at home, and I will show you my home-built little baby that I have that I drag around the yard. And when my husband is out mowing, I have to run out after him and scream, "Don't mow over my lines," and move it around. So I'll show you some of this. And like I said, it's something that I hobby with because my home in Ridgefield is not actually conducive or a good place for wind power. And so common 5 things that I want to think about is my generator, the blade structure that I'm going to build, how I'm going to mount it. So am I trying to keep it up into the air and how I'm trying to do that? Some type of tower to mount it on, or low speed shaft tower that I'm going to mount my vertical axis wind turbine blades on, and then how I'm going to store my energy. So my batteries or my control system, or if I'm pumping it directly into the home. As far as generators, you can use any generator you want. You can even jump on a Hobby Lobby nowadays and buy yourself up a small hobby generator to do your purposes. But one of the things that works really great if you can get your hands on it is an old tape generator, one of those old DC motor magnet generators that are from old tape drive computers, the early giant clunker computers in the 1970s. They last forever. These things are like indestructible. One of the things that you're going to want to look for when you're going to buy a generator is something with the lowest number of rotations per minute. Because if you're building it yourself, you're not going to get a lot of rotation. So you're going to look for the lowest number of RPMs on there. You're going to want something that's like a 325, which is sort of a standard, hooks up to a 30-volt battery style generator system. As far as blade structures, you can build the blades however you want, but this is just one that I cut out of PVC piping. So I took the PVC pipe, cut it in half, and then cut the structure. I thought about how to mount it, and I just kind of took a walk around at the time it was Tractor Supply, so I was at Tractor Supply till I found sort of the right things, and I found this gear set at Tractor Supply that was perfect for mounting my blade structures on. And then I found one of those cap domes that go over a septic well head, and purchased one of those to throw on top to kind of create that nice air stream, so that when the air is, this is a downwind system, so when the air is coming up and across the blade structures, it can then flow off the base without creating little eddies or turbulent activity of air behind. The next one would be mounting. I want to think about how I'm going to mount my little tape drive with the tail, and I'm going to want to create a tail that is held aloft that will always move downwind. So I need to put a little airfoil on it to give you that spoiler effect, right? So it's almost like talking cars here. On this note, I'm going to pick up with part 3, and we're going to talk a little bit more about how we build one of these systems ourselves, and then we'll talk about